This is Dr. Lakshmi, Professor and Head, Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology, Kanyakumari District. And in this first video, we'll see about the PN junction diode. So on completion, the student will be able to define PN junction. They will be able to explain what is forward bias and what is reverse bias. And they will be also able to explain what will be the Bi characteristics of diode. So diode, it is a semiconductor diode which is formed with pieces of P-type and N-type material when it joins. The P material is called the anode, whereas the N material is called the cathode. The resulting structure in the figure shown over here is called PN junction. A PN junction, or as we have two materials, it is called as a diode, which will act as a switch or component through which electrons will flow easily in one direction but not in the opposite direction. So how to bias the PN junction? To get current flow in PN junction or the diode, we need to apply an external voltage which we call it as bias. So with this connection, current only flows freely from cathode across the junction to the anode. So you would say that the switch is closed when electrons can flow through the diode. So the important thing to be noted over here is the current flow may be so high that an external resistance R is usually needed to minimize the current flow to a level a diode can withstand. So that's why you can see here, so to the diode we connect a resistance which is connected to the battery. So this arrangement we call it as forward bias. So you can see here the P type is connected to the positive terminal of the battery, whereas the negative terminal is connected to the N type of the diode, that is the cathode material. So the reverse bias is the reverse case. So a diode with an external voltage polarity reversed, we call it as a reverse bias. So obviously there will not be a current flow, and you could say here the switch is open when electrons cannot flow through the diode. So from the diagram you could see here the P, which is a positive material, or the P material is connected to the negative terminal of the battery, whereas the N material is connected to the positive terminal of the battery. So this is why you say here polarity is reverse, we call this as a reverse bias. So this is the diode symbol. Of course we know P and N, which is anode and cathode, which will form a diode. So we use this symbol shown on the right. So you can see the designations, which is P and which is N, and that is for anode and cathode respectively. So what will be the direction of current flow, which is electron flow, is shown by the arrow. So it is from the anode to the cathode, that is the conventional current flow, whereas the electron flow is the in opposite direction. So what would be the voltage drop at the diode? So the diode also have a voltage drop while they are conducting. This is called forward voltage drop. It is in the range of 0.5 to 0.9 range for the silicon diodes, whereas a typical value was 0.7 volt, which you can see in the diagram. The forward drop in a germanium diode is 0.2 to 0.4 in voltage range. So diode also have a threshold voltage approximately equal to the forward voltage drop. So this is the minimum amount of forward voltage that must be applied to get the diode to conduct. So once you connect it to the forward bias, you could obviously see that the diode will conduct only after 0.7 volt. For example, if you are applying a forward bias of less than 0.7 volt to a silicon diode, say, or less than 0.2 to 0.4 in the case of a germanium diode, so it will not conduct. As soon as the bias voltage rises above 0.7 volt, the diode will conduct. So that is actually you call it as diode threshold voltage. So only after this threshold voltage, the diode will start conducting. So PN diode characteristics. So obviously here we have forward bias and the reverse bias. So the external battery makes the anode more positive than the cathode in the case of forward bias. So the current flow will be in the direction of the arrow in the symbol. So which I have shown over here in the above diagram. And similarly, the reverse bias, where the external battery makes the cathode more positive than the anode. A tiny current will flow. You cannot say that there will not be any current flow, but a minimal current will flow opposite to the arrow in the symbol. So this represents the PN junction diode Bi characteristics. So you can see two bias regions. So one is forward bias region, the other one is the reverse bias region. So you can see in the forward characteristics, which is plotted against the voltage and the current. So after this 0.7 volt in the case of silicon and 0.2 or between 0.2 to 0.4, the voltage keeps increasing. That is the voltage or the current keeps increasing in the forward bias region, whereas in the reverse bias region you could see here after the breakdown voltage, which is represented here as VBR, the voltage keeps increasing. That is the current, it keeps on increasing, maintaining a particular voltage. So this is the mathematical approximation which you can write, where this ID is a diode current which is given by Is e power Vd by eta Vt minus 1. So this is actually the mathematical approximation for the characteristic curve which is shown over here. And this is the ideal PN junction diode Bi characteristic. So forward bias, it is compared to a short circuit, and in the reverse bias it is compared to a open circuit. But this is not at all possible practically. So this is that's why it is represented here as an ideal. So the characteristics of diode. So diode always conducts in one direction. So diode always conduct current when forward biased. Diodes do not conduct when reverse biased. The reason is you have the zero resistance in the forward biased, whereas in the reverse bias you have an infinite resistance. So the possible assessment question could be like, what is PN junction? Define voltage drop in the forward bias. What are the characteristics of the diodes? Thank you.